Hey, good morning, everybody. I've got one copy of this paper, so let's hope to goodness I don't mess it up. Today we're going to talk about interior angle sum, like how many degrees are in each of these shapes, and how do we know, like how many degrees are in a 30-sided shape, and how many degrees are in a 122-sided shape, and that kind of thing, because those things do exist. You don't run across them too often. So let's talk about these real quick. Here we have triangle, that's quadrilateral, pentagon, hexagon, seven-sided shape. There's a couple of names for that. It was originally referred to as a septagon, kind of not like the Transformer, not a Decepticon, just a septagon. But they changed it to a heptagon. We'll talk about that later. And then here we have an eight-sided shape, which we all know is called an octagon. So again, this is a 3, that's 4, that's 5, that's 6. I knew that bell was coming. That's 7, that's 8. All right, so the number of degrees in a 3-sided shape in a triangle, we know it's 180. And after our last unit, you know a 4-sided shape is 360. Well, if you notice, it increased by 180. And I'm just going to go ahead and tell you that that pattern continues all through the rest of this. So 180 plus 360 is 540. And 180 plus 540 is 720. And 180 plus 720 is 900. And 180 plus 900 is 1080. So here's the thing. We need to figure out a rule. This is something that nowadays is kind of overlooked some in algebra because everybody's pushing the EOC test to make sure everybody passes and gets credit for that class and everything, and so everybody's stressing about that. And a lot of times this little tool is overlooked, and it's kind of sad that that happens, but it's just one of those things that does. So I'm going to try to teach you real quick how to find a rule, an algebraic rule to go along with this. Okay, so I'm going to write on the back of this paper real quick. Let's say we have this pattern. Let's say we have a pattern like 4, 6, 8, 10, 12, ... Okay, well, to write a rule for this, you have to see how much is it increasing each time, and so you put 2 and that and the letter X, or in this case we're going to use the letter N. Now the letter N stands for, in this case, the number, what number position are we looking at here? So this is the first position, this is the second position, this is the third, the fourth, the fifth. And so if I plug any of these numbers in, I should get this number. So if you pick one of these and you plug it in, you've got to see, do you get the answer that you're supposed to have? So if I plug in, let's say I plug in 5, 2 times 5 is 10, but 5 is supposed to give me 12. So you got to ask yourself, what do I have to do to 10 to make it 12? And the answer is you just add 2. So it's 2n plus 2. All right, so that would be, and so if we try again, let's plug in, say, 3. 2 times 3 plus 2, well, that's 6 plus 2 is 8, and that's what you're supposed to get. Okay, another one real quick. Let's see, how about 3, 6, 9, 12, 15, ... Okay, so on this one, I see it's increasing by 3 each time. So I say 3 times n. And again, this is the first position, second position, third, fourth, and fifth. Well, 3n, if I plug in, let's say, a 5, 3 times 5 is 15. So we're good. We're done. This is the actual rule for that. All right, now, there's another one. All right, another one would be something like 3, 8, 13, 18, 23. All right, and so when I'm doing that, you can see that it's increasing by 5 each time. So I put 5 in, and again, this is our first position, second, third, fourth, and fifth. And it doesn't matter which ones you pick, I'll pick number 4 this time. If I plug in 5 times 4, I get 20, but I'm supposed to get 18. So what do I do to 20 to make it 18? And that is you subtract 2. All right, and so now when I plug in, say I plug in 2, 5 times 2 minus 2, 5 times 2 is 10, minus 2 would be 8. That's the right answer. Okay, if I plug in the 3, 5 times 3 minus 2, 5 times 3 is 13, minus 2 would be, 5 times 3 is 15, minus 2 is 13. So that's the right answer too. So this is the rule for that. Well, we have to find a rule for this, okay? But we don't have the first position, the second position, the third position. We have the third position, the fourth position, the fifth position, the sixth position. Okay, now we already know it's increasing by 180 each time. 180 in. But if I plug in any of these numbers, let's see, let's plug in 5 because 5's easy. Okay, 180 times 5. 180 times 5 is 900, but it's supposed to be 540. So what do I have to do to 900 to make it 540? Okay, and if I have 900 and I want it to be 540, I've got to subtract. And if you do the math, you should see pretty quick, you have to subtract 360. So 180 times n minus 360. If I plug in any of these numbers now, let's plug in an 8 just to show you. 180 times 8 minus 360, and you know what, just for kicks, let's throw in a 4. 180 times 4 minus 360. Now I should get 1080 for this one and 360 for this one if I did it right. Grab my calculator. Alright, so 180 times 8 minus 360 is 1080 like it's supposed to be, and 180 times 4 minus 360 is 360 like it's supposed to be. Now here's the thing though, while this is the rule and it does work, in algebra you learn about simplifying. And there is a way to simplify this so that it is easier to work with. This will work, but because I understand factors and I understand how many times something goes into something else, I see that I could factor out the 180. 180 goes into this one time and it goes into that 2 times. And so 180 times n minus 2. Okay, so it'd be a minus 360. See, because now if I distribute this, okay, I would get this. 180 times n, and 180 times negative 2 would be minus 360 or negative 360. Okay, so 180 n minus 360. This and this are the same thing. This one, however, is easier to use, and that's the one we're going to use from now on. Actually, I'm going to tell you this. If you have n, it's easier to use this one. If you don't have n, it's easier to use this one. Okay, so we're actually going to use both of them. This is the one we want to use if we have n. This is the one we want to use if we don't have n. Okay, and what this equals, by the way, I really should rewrite this. It's 180 n minus 360 equals the sum. Okay, or 180 and then n minus 2 equals the sum. All right, see on this one, you would have to multiply a number times 180, which means you need a calculator, and then you would have to subtract 360, which probably also means you want to grab a calculator to do it quickly. But on this one, you're going to subtract 2 from whatever number you have. And so this one's going to, you could do that in your head and then just multiply by 180, which means you need a calculator for that, but this one's just quicker. Okay, so let's take a look at this first example. Sorry I went into a big long explanation of that. The rest of this goes pretty quick. A 23gon has how many degrees in it? So what we're going to do is we're going to use this one. Okay, we have n, this is our n, how many sides? The number, n equals the number of sides. Okay, so a 23gon has how many degrees in it? So if I took this equation, 180 n minus 2 equals the sum, that's what I'm looking for, the sum. I have n, so I'm going to use this one. It's going to be 180 times 23 minus 2, that's going to equal my sum. 23 minus 2 I can do in my head, that's 21. 180 times 21, I don't know. That I need my calculator for. I'm not going to lie, I don't know what the answer to that is. 180 times 21 is 3,780. And that is how many degrees it is. All right, on this one. Now, normally what we would have to do is we would have to use the formula to find out how many degrees are in the shape. But if you count sides with me, by the way, here's the best way to count sides. As you're counting, put a dash on it. 1, 2, 3, 4, 5, 6, 7, 8. This is an octagon. We already have that answer. The answer to how many degrees are in an octagon we have written up here, it's 1,080. Okay, but if let's say this had been a 13-sided shape or a 19-sided shape, you would have to do the formula to find the answer. Okay, but we know that all of these degrees are going to add up to be 1,080. And so we need to put down that 120 plus 130 plus x plus 130 plus 130 plus x plus 140 plus 150 plus 120, all that equals 1080. All right, now you see what I did? Okay, I made a mistake on purpose. Okay, you got to be careful that you know where you started and where you have to stop from. So honestly, as you're writing these, I would go through and kind of circle them. 120, 130, x, 130, 130 again, another x, 140, 150, and that should not be there. Take off that 120. All right, be very careful you don't put too many or not put enough. So now we need to combine all our like terms. So let's see, 120 and 130 be 250, that'll be 380. I'm not doing that. Are you crazy? I'm not even going to try. It is way too early for that. 120 plus 130 plus 130 plus 140. Why is sine on there? I'm sorry, guys. Excuse me. Clear. 120 plus 130 plus 130 plus 130 plus 140 plus 150. What? I'm hitting plus. Why am I? Man, I am messing all up today. 120 plus 130 plus 130 plus 130 plus 140 plus 150 plus. Whew, man. So all of that, all the numbers are going to add up to be 800, and there are two x's, so that's going to be 2x, and all that's going to equal 1080. If I subtract 800 on both sides, then I get 2x equals 280, and then if I divide both sides by 2, x is going to be 140. There we go. All right, a polygon has an angle sum of 9,000 degrees. How many sides does it have? All right, in this case, because we don't have n, we're looking for the number of sides. We're going to use this formula. 180n minus 360 equals the sum. That's the formula we're going to use on these. It makes it easier. It just does. Okay? So we know the sum is 9,000. So 180 n minus 360 equals 9,000. Well, the first thing you do to solve this is get rid of that minus 360. So you have to add 360 to both sides. So 180n equals Well, 9,360. That's not too difficult. And then you have to divide by 180. And everybody knows when you divide 9,360 by 180, you get, I don't know. Let me look. I really don't. I have no clue. Let's see. Clear. Okay. 9,360 divided by 180, did I type that in right, is 52. Now, this is a 52-sided, it's a 52-gon. It's a 52-sided shape. Now, here's the thing. Please note that on a question such as this, you cannot get a decimal. How many sides does it have? It cannot have 48.7 sides. Okay, if it had 48.7, it would be 49. Okay, but that doesn't mean you get to round up. No, no, no. If you get a decimal, you're wrong. Okay, you cannot get a decimal when the question is how many sides does it have. That's like me asking you, hey, how many sisters do you have? And if you say 1.3, that's messed up. Okay, that's really, something is wrong at your house. All right, if you have 0.3 of a sister laying around somewhere. Okay, I'm just saying, that's not okay. So, you cannot have a point side. All right, so another thing you received is this little table, and I'm going to help you fill it out real quick. So, I'm actually going to go ahead and tell you the answers for this column, even though you should have gotten them already. But a polygon name, a three-sided, you should know, is a triangle. A four-sided is known as a quadrilateral. Please don't put rectangle. That's usually what I get right there. All right, that's not the name for any four-sided shape. That's the name for a specific four-sided shape. This is a pentagon. This is a hexagon. This is a heptagon. This is an octagon. This is a nonagon. I know, it's kind of a weird name. This is a decagon. This is a undecagon. Decagon. Un, like uno, one, and dec, meaning 10, so undec, 11. And this is a dodecagon. Like dos being 2 and dec being 10, so 2 and 10 make 12. And anything above 12 used to be you had to know the names for all of those, but luckily in like the 1960s they went through and they decided to change the rule and said high school students only had to know 3 through 12, and so anything past 12 is an n-gon. Isn't that nice? All right, for the interior angle sum, this is what we did today. We already figured out this is 180, this is 360, this is 540, this is 720, this is 900, this is 1080. If you continue, if you use the formula, or if you just add 180 to these, 180 plus 1080 is 1260. And then we should get, to see, 180 on top of that would be a 40, should be 1440. And then we get 1620 and 1800. And then the n-gon, this part right here, this is where we put the 180 n minus 2, or 180 n minus 360, depending on what kind of problem you have. If you have n, you use this one. If you don't have n, you use this one. And again, this equals the sum. Okay? If you have n, you use this one. I'm going to underline that. If you have n, you use this one. If you have the sum, you use this one. All right, I hope that helps, folks. We're going to fill out the rest of this table as the unit goes on. And good luck to you.